Hello and welcome, ladies and gentlemen. We are still in Packet 5, working through Activity 5.3 now. So here we are, perimeter and area of a composite figure. Okay, so they have all of this talk up here. I'm not going to read the whole thing to you, but basically what they're talking about, the main thing that they want you to know is a composite figure. They want you to learn that vocab word. They want you to know that. Okay, so when Mr. McGill says composite figure, you know exactly what I'm talking about. So here we go. So a composite figure is a figure that is formed by combining different shapes. Okay, so example, if I have a square, that's just a square. But if I have a square and this triangle, and then I combine the two, and then I make something that looks like this, you can see I still have my square and my triangle. That's a composite. It also is a trapezoid in this case, but you can see from this graph down here, okay, we're going to get kind of a crazy one. So this is combining a bunch of different shapes. My simple example is just combining two, but it's the same thing, okay? So here's our problem. The beginning of our problem actually starts right here, so I'm going to go ahead and read this. Carter has an irregular backyard because it backs onto the foothill of a mountain and is very rocky. The composite figure graphed on the coordinate plane represents the flat area of Carter's backyard. Each interval of the coordinate plane represents 2 yards. Okay, so that means that so each square is 2 units. Okay, and we've kind of talked about that in previous videos. Reading graphs, I know you all can do that. Okay, so question 1. Carter will install fencing all around the flat area of his backyard. Determine the amount of fencing he needs to the nearest whole yard. Okay, so first of all, let's do this. Okay, to the nearest whole yard. So let's double check our units because we want to know want to know the perimeter or the area around this shape in yards. So it does in fact say each interval on the coordinate represents 2 yards. So we don't need to worry about units right now. Okay, so basically what we're doing is we're doing a perimeter of this complex figure. Okay, so in order to do the perimeter, remember the perimeter is a distance around a shape. So what we're going to need to do is find the length, side lengths of all of these individual lines here. Okay, now the nice ones, the easy ones, are the ones that are either horizontal on grid lines or vertical. Okay, so for horizontal ones and vertical ones, we can just count squares. So I'm just going to do that for as many as possible until we have to do some, like these diagonal ones, we'll have to do some distance formula. Okay, so I'm going to start with line AB right here. Okay, so line AB, it goes 1, 2, 3, 4 squares. Each square is 2 yards, so it's going to be 8. Okay, and then we can go ahead in yards if we'd like. I'm not going to put that for everyone, but you can do that if you'd like. Okay, for line BC, we're going to wait on that one for now because we'll have to do some distance formula. For line CD, it is 1, 2, 3 squares tall, so it's going to be 6 yards. For DE, we go, say, so this starts on a half unit, so 1, 2 squares, which is going to be 4. For EF, okay, for EF is 1, 2, 3 squares, which is going to be 6. For FG, we have, again, this is on a half unit, so, or half square, so 1, 2, 3 total, which is going to be 6. For GH, we'll wait on that one because we'll have to do distance formula. So now for HJ, we'll go up 1, 2, 3, 4, 5, 6, 7, 8, 9 squares, which is 18, remember, because each square is 2 yards. And then for the last one, AJ or JA, either way, this is 1, 2, 3 and a half. So each square is worth 2, so 3.5 times 2 is 7. Okay, so those are all the side lengths, not including our diagonal ones, which we're about to do. Quick note on something that I think is kind of funny. If you do the alphabet, A, B, C, D, E, F, G, H, I, J, oh, what? Where? There's no I in here. I think it's funny that they were going alphabetically and somehow skipped an I. I guess if you wanted to get real creative, you could say that this big tall line was their I, but I think that they just goofed up, you know, new curriculum and all that. I don't think you can hear it in the background, but if you can hear that man on his motorcycle outside, I apologize about that. So here we go. So now we got to do some distance formula for these two. Okay, so for line CB, I'm going to do a distance formula. I need 2 points for that. So for point B, we go over 2 because, well, we go over 1.5 squares. Each square is 2 in length, so we go over 3. So for B, our ordered pair is 3, and then it goes down 1 square, which is -2. And then for C, Okay, for C, I go back 1, 2, 3.5. So 3.5 times 2 is 7, so -7, and then it is 2 tall, which is 4. Okay, so I'm going to go ahead and go x1, y1, x2, y2. So I'll have -7 minus 3 plus 4 minus -2 squared. So -7 minus 3 is -10, that squared, plus 4 minus a -2 is like adding a 2, which is going to be 6 squared. 100 plus 36, square root of 136. And then my phone is still being strange from the last video. So Siri, what is the square root of 136? She got all of that. She heard all of it.
Here's what I found on the web.
Here we go. We'll try one more time. Siri, what is the square root of 136? Ah.
The square root of 106.30.
Siri, what is the square root of 136?
The square root of 136
There we go. Okay, isn't
11.
technology beautiful? It works the first time, every time. So 11.66, okay? And then I will come back, we'll do some more talking to Siri in a second. Hopefully she'll be better for us this next time. So that was the length of CB. So now I need the length of GH. In order to do that, I'll need some ordered pairs. So I'm going to do GH right here. So the x value for G, and G is actually in line with B. So we can use the same x value, it's just going to be 3. And then for G, we go down 1, 2, 3, 4, which is going to be -8. Now for H, we're out here 2, 4, 6, 8, 10. And then we're down 2, 4, 6, 8, 10, 12. -12. Perfect, okay? So for this now, I'll go x1, y1, x2, y2. So I'll have 10 minus 3 squared plus -12 minus -8 squared, which gives me 7 squared plus -12 minus a -8 is like adding an 8, so -4 squared, square root of 49 plus 16, the square root of 65. So here we go. One time, Siri. Siri, what's the square root of 65?
The square root of 65 is
There we go.
approximately 8.06.
8.06. Perfect. Okay. So now I have all of these side lengths, and I have the 2 diagonal side lengths as well. Okay. So this was CB. This was GH. Oh, I'm off the screen. This was GH. Okay, so now we can add all of those together for the perimeter. Okay, so I'm actually just going to do it on this page instead of flipping it over and adding those up, just because we can do it right here. Okay, so, and I guess I'll show you guys a trick of how I would do this just in my head. I'm not going to do the whole addition in my head, but I'll do most of it in my head. So 8, 6 is 14. So basically I'm just going to do one addition at a time. So 8 plus 6 is 14. 14 plus 4 is 18. Plus 4, or plus 6, excuse me, is 24. Plus 6 is 30. Plus 6 is 48. Plus 7. Wow, I kept saying plus 6. So here we'll start over. 8 plus 6, 14 plus 4, 18. 18 plus 6, 24. 24 plus 6, 30. 30 plus 18, 48. 48 plus 7, 55. Okay, so now I'm at 55 plus these two numbers instead of doing all of it, writing it all out. Okay, so 11.66 plus 8.06, and then I will go ahead. I won't ask Siri this time. I'll just go ahead and plug it in. So 55 plus 11.66 plus 8.06, 74.72. Okay, so that is our perimeter. That is the answer to question 1. So coming back here, 74.72, and all of our work was on that front side. Sorry for the shaky cam. Carter wants to lay grass sod in a flat area of his backyard. Determine the total area of sod he needs. So now, okay, so we did the perimeter. We did the perimeter of the shape. Now we get to do the area. Fun times. Okay, so the way that we can do this, there's a couple ways. There's one way that I think is much more efficient than the other, so I'm going to do that way. Okay, the other way, so one way that you can do it is you can construct a shape around this. So you could do like a big square or something, or a big quadrilateral, and then subtract shapes away from that. So say I went like out here, and then I came down here, and then I connected it right there. So you could find the area of this big thing and then subtract the little ones, like this stuff on the outside, right? Or the way that I like to do it, I like to work from the inside and create shapes on the inside of this, and then calculate those. So hopefully as you guys do more of these, you'll get better at seeing shapes. The way that I see this, so this looks a lot like a triangle to me, so I'm going to section this off. Okay, and then this looks a heck of a lot like a square. Okay, and then right here, this looks like another triangle. Okay, and then you'll see we're left with this big rectangle right here. So instead of finding the shape, like looking at finding the area of this shape on its own gets a little scary, but when you look at finding the area of a triangle, less scary. Square, triangle, rectangle, right? We can do all that, no problem. So that is in fact what we were going to do now. I'm just going to do these calculations on a separate sheet of paper because I don't want to have to flip back and forth as we try and do this. Okay, because technically I would do the work on the other side of this sheet, but like I said, I don't want to flip back and forth. So for this area, okay, we're going to do this triangle. So remember, triangles, area equals 1/2 base times height, right? So 1/2 base times height. So what's my base? It's 1, 2, 3, 4, 5 squares, which is 10. So it's going to be 1/2 times 10, and then the height is 1, 2, 3 squares, which is going to be 6. So 5 times 6 is 30. So that means that this triangle up here has an area of 30. Okay. Now I said that this looks like a square. I am going to count the side lengths just to be absolutely sure. Okay, it is a quadrilateral. So this top side from here, 1, 2, 3. Okay, so that's going to be 6 times, and then this does drop down 3, so 6 times 6. So this area, 36. Okay. Now I'll do this triangle down here. Base times height, or 1/2 base times height. Okay, this base is 1, 2, 3.5, 7. So 1/2 times 7, and that's because 1 square, 2, 3, and this half, and then each square is 2 yards. Okay, and then the height is 1, 2, which is going to be 4. So 1/2 times 7, 7/2 times 4 equals 28/2, which is 14. Okay, and then now I need to just do the area of this big rectangle here. Okay, so we said that side AJ, whereas AJ is 7, so I already know that. And then now I can just count the height. We do have the height of JH, but remember, or HJ, okay, we do have that height, but our rectangle is not that tall because it gets cut off right here. So we can do HJ, which is 18, minus these 2 squares that are part of our triangle would be minus 4, so then this would be 14. 7 times 14, some mental math if you'd let me, is going to be 70 and 28, it's 98, okay? 98. So now for the area of this, now we're just simply adding all of these together. And this one I'm not going to try and do mental math. I'll just go ahead and stack them, do it old school. Okay, adding all of these. 6 plus 4 is 10, plus 8 is 18. Put this 8, don't forget to carry the 1. 9 and 1 is 10. 6 more, 3 and 3 is 16, 17. Okay, so 178, and then that's square yards, which will be important later. Okay, so, oh, and then also for our perimeter, that was in yards, and then 178 square yards. Okay. So compare the method you use to determine the area of sod Carter needs to your classmates' methods. I don't have a classmate here, so we're just going to go ahead and not worry about that one. Basically what they're trying to get you to see is that there's a lot of different ways that you can break up the shape. Kind of like I said, you can start from the outside and work in, you can start from the inside and work out, and even the way that I did it isn't necessarily the only way to do it. I mean, if you wanted to, you could break this square up into triangles. You could do all kinds of crazy stuff. I do think that this is the most efficient way to break this shape down, but it's not the only way. Another way, you could like make a rectangle here, right, and then you'd have this rectangle and then that kind of rectangle there. So they're just basically trying to get you to see that there's a lot of different ways to do it. Okay, so now part 4. Fencing costs $5.45 per foot, and sod costs 62 cents per square foot. To allow for measurement error, Carter plans to buy an extra 10% of both materials. How much will it cost Carter to purchase these materials? Okay, so we have everything that we need on this page, so I'm just going to go ahead and do the work here. Okay, so we said that our perimeter was 74.72 yards. Okay, so one thing we need to be careful about is that this is in yards and it says 5.45 per foot. So we need to convert our yards to feet. So really fast, there's me and my dad. Okay, 74.72 times 3, because there's 3 feet in 1 yard. So 224.16 feet. So this was times 3 equals 224.16 feet. Okay, and it says that for measurement error, he plans to buy an extra 10% of both materials. So there's a couple ways that you can do this. You can take 224.16. You can multiply it by 0.1 to get 10% of that, and then add that to here. Okay, the easier way to do it is actually just to take 224.16 and multiply it by 1.1. So the reason this works is because when you multiply something by 1, you'll get that same number back, right? So 224.16 is going to be, times 1 is going to be 224.16. But by multiplying it by this 0.1 in addition to that, you're already adding that 10%. So you just save yourself one step on your calculator. You get the same answer, so it doesn't really matter, but just a little easier thing for when you're calculating things. So now that means that he's going to buy 246 and we'll say 5.8 feet of fencing. So again, we went from yards times 3 to feet, and then he's buying 10% more, which is right here. So this is the plus 10%. Okay, and so now we need to take this number, 246.58, and multiply it by our cost, so 5.45. So he's going to spend a lot of money, $1,300. Okay, so we're going to go 1343.86, and we'll round to the nearest hundredth because we're talking about money. So he's going to spend $1,343 on fencing. So now we still need to calculate, though. We still need to calculate the area, or the sod, okay, that he's going to lay. So this one, okay, we had 178 square yards, and it's 62 cents per square foot. So again, we need to do a conversion here to get it into square feet before we can work with this. So the tricky part about this is that most people want to go square yards, multiply it by 3, just like we did here, to get to square feet, but we can't quite do that. And the reason that is because of this. So if I have a square yard, okay, and I have 1 yard by 1 yard, okay, and I wanted to break this square up into feet, each yard is 3 feet. So 1 square yard is actually a 3 by 3 of square feet, so it's actually 9 square feet. So I need to take this, 178, and I need to multiply it by 9, okay? I got my phone over here still that I'm working with. Gives me 1,602 square feet. Okay, now again, we said that he plans to buy 10% extra, so I'm going to do that 1,602 times 1.1 again to give me 1762.2. He's going to buy that many square feet of material, and then we said our cost was 62 cents per, so I'm going to go times 0.62, which will give me, and then this is money now that we're talking about, 0.56. Okay, so now I have these two values, 1343 and 1096. So I'm just going to go ahead and add those together. I'm going to do it off the screen here so you guys can still see both the answers. 1343, 1092. Cool. So our final answer, if we add these together, $2,400, 36 cents, and 42 cents, and that's just combining those two. So this would be his total cost for everything. Okay, so 5.3. Not too bad, just under 20 minutes. So shortest video so far other than the very first one, but we're getting there, guys. So thank you so much for watching. I'll see you guys in class. Let me know if you have questions. Have a great day.